Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurwaida binti Ismail, and today our group will present to you about the project assignments for signal and systems. This project focuses on application of signal and image processing techniques using MATLAB. Throughout this project, we perform 4 different tasks involving the convolution, Fourier series, fast Fourier transform, and image filtering. These tasks allow us to understand how signal and image can be analyzed, processed, and transformed using various techniques. Also, this project provides us with hands-on experience in using MATLAB to simulate, visualize, and interpret the results. Overall, this project helped us to strengthen our understanding of signal and system concepts while improving our programming and analytical skills. For our first task, which is task 1, convolution of one-dimensional signal. What is convolution? Convolution is a method used to determine how a system responds to an input signal. So in this task, we recorded the voices of all group members and combined them into one audio signal. How we do it? First, we imported the audio recording into MATLAB using the audio read function. Since the recording was in stereo, so the code converted it into a single channel signal by averaging both channels. Next, we created an impulse response to simulate an echo effect, where the original sound has an amplitude of 1 while the echo has an amplitude of 0.5, and it will appear after the delay of 0.25 seconds. Then we use the coding conv or conv function to perform the convolution and generate the output signal. Lastly, the code plotted the waveform of the original signal, impulse response, and output signal, and the audio was played for comparison. So, through this task, we were able to understand how convolution modifies an input signal and produce a new output based on the characteristic of the system.
Hi, my name is Nurwahida and my matrix number is B122510625. Hi, my name is Nurwahida and my matrix number is B122510625.
Hi, my name is Ira. My number matrix is B1225106448. Hi, my name is Ira. My number matrix is B1225106448.
Hi, my name is Aisha Tuafira and my matrix number is B122501. Hi, my name is Aisha Tuafira and my matrix number is B122501.
Hi, my name is Muhammad Faiz and my matrix number is B122510584. Hi, my name is Muhammad Faiz and my matrix number is B122510584.
From the result obtained, we observed that the output signal became longer after the convolution process. An echo effect could be clearly heard in the output signal, and the amplitude changed depending on the impulse response used. These observations shows that the convolution affects both the duration and characteristic of the original signal. Therefore, convolution can be used to describe how a signal behaves when it passes through the system.
Hi, my name is Nordira Adlina binti Muhammad Rosdi. My number matrix is B1225100648. Today I want to explain about task 2, Fourier series. Fourier series shows that a complex signal can be built by adding simple sine wave, which is harmonics. In this task, a 10-second song was created by combining several harmonics, and each waveform was analyzed to understand how it contributes to the final signal. So, this is the code generate a 10-second musical signal by combining 3 sine waves, which is harmonics in MATLAB. It used a sampling frequency of 42,000 Hz, a fundamental frequency of 261.63 Hz, which is C4 notes, and create first, second, third harmonics. These harmonics are combined to form a richer sound. The code also plots each harmonics and the final signal, then plays the sound using the sound function. So this is the result. So, the observation for this result is first harmonic give the main tone, second, higher harmonic improve sound quality, third, combining harmonic create a musical signal. Lastly, for the series signal.
Assalamualaikum, my name is Muhammad Faiz bin Muhammad. My matrix number is B122510584. I will present the task 3, fast Fourier transform FFT. As shown on the slide, FFT is used to convert an image from spatial domain to the frequency domain. This helps us analyze the image by looking at its frequency components such as overall structure and edges. For this task, we use a group photo as the input image. First, it was converted to grayscale. Then 2D FFT was applied to transform it into frequency domain. Next, FFT shift and log transformation were used to make frequency spectrum easier to observe. Finally, IFFT was used to reconstruct the image back to the spatial domain. The reconstructed image is almost the same as the original, showing that the image information was preserved. This is the task tree result, like I was said in the previous slide, from original color image to grayscale image, and then Fourier transform, and then centered Fourier transform. After that, log transform image. Lastly, reconstructed the image. So, the observation that we can get from this, FFT transform the image into frequency components. Low frequencies show the overall structure. High frequencies show details and edges. And lastly, the reconstructed image was close to the original.
Hi, my name is Aisha Tuafera. My number metric is B1225108886. So now I'm going to explain task 4. So task 4 for part 1 is convolution of two-dimension signal using a Gaussian filter. In this task, we use our original color image and apply Gaussian blur to smooth the image and reduce the noise. Gaussian blur works by convolving the image with a Gaussian kernel. This means that each pixel is replaced by weak average of its neighbor pixel and producing a smooth image. To observe the effect Gaussian filter, we test 4 different sigma values, which is 1, 3, 6, and 15. To propose of using a different sigma value, it is to compare how the amount of blur change as the standard deviation increase. So we can see in this slide we have 4 pictures, which is for picture 1 is Gaussian 1. So since the sigma value is small, only the small amount of blurring is applied. Most of the image details remain clear and the edges can still be seen clearly. So for the picture 2, here is the blur becomes more noticeable. So some fine details starts to disappear, but the overall image is still easy to recognize. So for picture 3, is we using 6 Gaussian. So more details are removed and the edges become softer. This level of blur is useful when we want to reduce more imagery noise. So and the picture number 4, the last one, is we using a Gaussian 15. So most email details are lost and only the general shape remain visible. Although the image became very smooth and its sharpness is greatly reduced. Now I will explain task 4 part 2, which each detection using Leftian of Gaussian or LOG filter. Unlike a Gaussian filter in part 1, which is used to blur the image, the LOG filter is used to detect edge or boundaries of object in the image. So the LOG filter firstly smooth the image using Gaussian filter to reduce noise, and then apply the Leftian operation to highlight areas where the image intensity change repeatedly. So this area represent the edge. In this task, we use 4 different sigma values, which are 0.2, 0.4, 0.6, and 1. To observe how the edge detection change will different with different levels of smoothing. So this is the output that we get from our task 4 part 2. The first picture is before we apply LOG filter. It used to reference for comparing all the edges and the detection result. So for number 1, images for 0.2. Since the result value is very small, only a small amount smoothing is applied. As a result, many fine edges and the small details can be detected, but some image noise is also visible. Next, for 0.4, the images become slightly smoother, so some unwanted noise is reduced. The important object is boundaries is still clearly to detect. Next picture is 0.6. As we can see, it's applied before edge detection. most of the small details disappear, leaving only a stronger and the more important edges. And for the last one is number 1. Finally, the only main outline object remain visible. While many fine edges are no longer detected. This happened because a stronger smoothing removes both noise and small image detects. From the result, we can see the sigma value affect the edge detection performance, and therefore between detecting more detailed and reduced image noise.
In conclusion, this project gave us hands-on experience in signal and image processing using MATLAB. We successfully applied convolution to audio signals, created simple music using Fourier series, analyzed image using FFT, and used Gaussian and log filter for image processing. Overall, the project helped us better understand key concepts and improve our MATLAB skills. That's all from us. Thank you.